Good morning, children. Already we discussed in previous class about motion, isn't it? Types of motion, uniform motion and non-uniform motion. Already explained you. Uniform motion equal time, the object covered in equal time in equal distance in equal interval of time. And non-uniform motion in equal time, unequal distance, covered unequal distance is called non-uniform motion. Already I gave example also. Now coming to, apart from this motion, there are mainly the three types of motion are there. What are they? That is a translatory motion. There are three types of motion: translatory motion, and rotatory motion, and oscillatory motion. There are three types of motion: translatory motion, rotatory motion and oscillatory motion. I gave examples before also. Here you see the types of motions are given here. You are seeing the tree. You are seeing here tree that and the car is there. Car is moving along a straight line. Different examples are there. Car is moving along a straight line, traveling along a straight line, and here you are seeing the blades of a ceiling fan. You are seeing the motion of blades of a ceiling fan here and motion of a needle running sewing machine. The needle is going up and down here. And here pendulum of a clock. Here see pendulum of a clock, wall clock. This is a wall clock and this is the pendulum of a clock. So these are different examples are given for you here. Now here this car is moving in the same direction along a straight line, isn't it? And you are seeing here ceiling fan. The blades are moving in a circle. Isn't it? Moving, that is rotatory motion. And here you are seeing the needle, movement of a needle or motion of a needle which is going down and coming up and down you are seeing. In the same way, you are seeing the pendulum clock. The pendulum is moving left and right, left side, right side, left side, right side. You are seeing this, isn't it? So these are the different types of motions are there you are seeing. So pendulum of a clock you are seeing here. It oscillates, to and fro motion you are seeing here. To and fro motion you are seeing. So based on these types, these motions, it is divided into three types. That is a translatory motion, rotatory motion and oscillatory motion, isn't it? So here you are seeing here, observing the path of the motion. You are seeing here soldiers marching in a parade. It is a straight line or curved motion? Straight line motion. Car taking a turn on a road, it is a curved motion, curved line. Stone dropped from a height, straight line. It is a straight line. Running race along a road, it is straight line only. Running race along a track on a ground, curved line. Movement of a bicycle on a road, it is a straight line. So here, now types of motion, here we will see the types of motion. If all parts of the body moves in the direction of the motion, then it is said to be a translatory motion. In a straight line motion, it is said to be a translatory motion. If all the parts of a body moves along a straight line, it is said to be a translatory motion. It is called a translatory motion. Or if a body moves, if a body in translatory motion moves along a straight line, it is called rectilinear motion. Rectilinear translatory motion, same. RT. Rectilinear translatory motion. If a body in translatory motion moves along a curved path, it is called curvilinear motion. So here the examples are given for you: rectilinear, curvilinear or rectilinear motion. R is for rectilinear motion which moves along a straight line. Curvilinear motion which moves along a curved which moves along a curved path is a curvilinear motion. R for rectilinear, C for curvilinear. RC means rectilinear and curvilinear motion. Now here we'll see some examples are given for you. Seconds hands of a clock. Seconds hands of a clock, whether it is rectilinear or curvilinear motion, seconds hands of a clock which is moves in a curvilinear motion. It is in a curvilinear motion. Isn't it? Movements of a train on a track, rectilinear motion. Movement of a handle in a speedometer. Movement of a hand in a speedometer. Speedometer, it shows the speed of the vehicle. It is in a curvilinear motion. It is in a curvilinear motion. Example, see. Movement of a bus on a hill station. How the hill station will be? Straight line will be there, then U-turn will be there. Again straight line, then U-turn will be there. So, both motions will be there in this rectilinear and curvilinear motion. Both the types of motions are there in this. Motion of a coins on a carrom board. It is in a rectilinear motion. Isn't it? So, mango falling from a tree. Mango falling from a tree. It is a rectilinear motion, straight line. It is straight, it is falling. It is a rectilinear motion. So, you have seen these different types of motions. An example of rectilinear motion, curvilinear motion and translatory motion. Translatory motion which moves along a straight line is called translatory motion. Next, coming to rotatory motion. If all the particles of the objects moves in a circular path, it is called a rotatory motion. At a fixed point, it is called a rotatory motion. For example, ceiling fan. Ceiling fan. Motion of the ceiling fan. See, these are the fans, blades of the ceiling fan. All the particles of the blades are moving in a circular path at a fixed point. Is called rotatory motion. Is called rotatory motion. What are the examples of rotatory motion? Wheels of a car, wheels of a vehicle. Rotatory motion. Spinning top is a rotatory motion. Ceiling fan is in rotatory motion. Giant wheel is an example of a rotatory motion. Cooler fan is an example of a rotatory motion. You have seen potter's wheel. Potter's wheel, how it make the pots. It is also an example of a rotatory motion. You can write many more examples. Globe. Globe. Social, I think in social you have seen teacher showed you many times globe. It is in a rotatory motion. So which moves on its fixed axis. Rotation of the earth is in rotatory motion. So hands of a clock is an example of a rotatory motion. So these are the examples of rotatory motion. Understood? Next, coming to, even you can see the pedestal fan. Pedestal fan shows you two types of motions. That I will explain you. Rotatory motion, one more example, one more motion is there. I will explain you that. Now coming to next, third type of motion. To and fro motion of an object is said to be oscillatory motion. To and fro motion of an object is said to be oscillatory motion. Pendulum clock. Pendulum clock. It moves to left, right. Example of a oscillatory motion. Bumping ball goes up and down, goes down, up. Keyboard, when you press the key, it goes down, again it will come up. Again it will go down, again it will come up. So, to and fro motion of an object is said to be oscillatory motion. Ringing of a bell. Ringing, it goes front and back, isn't it? Swinging, cradle, front, back. Oscillatory motion. It is example of a oscillatory motion. Strings of a veena. Oscillatory motion. Movement of your hand and it strikes to other strings and gives you a music. Isn't it? Example. And the next pedicel fan. Pedicel is a standing fan. It's called a pedicel fan. Isn't it? Have you seen pedicel fan? We use in functions, very big halls are there, everyone will get the air. Isn't it? The movement of this fan, it moves to left side, then come to right side, then right side. So it has two types of motions. Movement of the blades of a fan is rotatory motion and movement of the fan from left to right is a oscillatory motion. Rotatory and oscillatory motion, two types of motion you will see in this pedicel fan. Isn't it? Next, Columbus. I think everyone visited the parks, Ocean Park and all. Columbus will go left, then come to right. Left, then come to right. It's an example of a oscillatory motion. Many more examples are there. Sewing machine. Have you seen the needle of the sewing machine? Goes down, come up. Goes down, come up. Example of a oscillatory motion. So these are the example of oscillatory motion. You can give many more examples of oscillatory motion. Bouncing ball. Goes down, come up. Goes down, come up. So these are the example of oscillatory motion. So we have discussed translatory motion, rotatory motion, oscillatory motion. This chapter is completely new for you. So remember this. Examples are also very important one. Remember, you can write your own examples. Also, rotatory motion, you will get many more examples. You will get oscillatory motion, also many more examples. You will get it. Find out other examples. I give many examples. Apart from this, find out other examples also. Thank you.